Plus pointers are to store address of other variable, and also C++ provides a pointer to store address of functions. To explain that, let me just create a new file and test.cpp. This is not a part of the project, but show you something about the pointer there. So let me include IOStream int main is there. So we have learned that I can define a variable and then I can define a pointer. Since it's integer pointer, I can store address of n, something like this. Suppose I have a function, void function 1, which takes one argument n, and what it does is print f1 and value of n endl, like that. And then suppose I have another function where the return type and the parameters are the same. The function name is different, and then it does a different thing. Then I can define a variable f where I can store name of the function. So name of the function is the same as address of the function is there. So address of the function is actually name of the function. So I can store a function name, since that is address, into a variable f. Then f is also pointer, but it's called the function pointer. Function pointer. The example of a p here was a integer pointer though. So function pointer, since the name of the function is address, so I can store into a variable. Then how do we define function variable? So f is a pointer, so for sure we need to give a star, and then that's part of the syntax to declare f as a function. And then in the f as a pointer, and then in this one we wrap up by parentheses, and then before the opening parentheses you specify return type of the function. The name of the function is to be stored. So f1 return type is a void, so I begin with the void, and inside the parentheses I give a star f, and then another parenthesis is needed where I should specify the parameter type. So here integer type, I have a parameter. It's there. So that's how to declare a function pointer. So pointer name or variable name is f, then star is needed. It's wrapped up by parentheses, and prior to the parentheses we give a return type of the function, and inside the parentheses we list the parameters, one integer there. And then if f is a variable, now I can store f2 as well. So here function pointer cannot store any arbitrary function name, but any function which has the same return type and same number of parameters and type of the parameters. So like f1 and f2, then you can store any of such names into f. Like if we had the integer pointer, all we can store is the address of integers only, not a double, something like that. The function has a more limitation, such that the function name can be stored into the function pointer, and then the function pointer defines the return type and parameter list. So only the functions with the same return type and the same parameter list can be stored into the defined function pointer. So if I have another function which have a double type variable, then something like this. Then if I try to store f3 into f, which is error because it only takes this kind of prototype only. So if you want to store f3, then I need to define another function pointer. So let's do as a function d. Then fd is a function pointer. So inside the parentheses, we do fd and then return type. And then in another parenthesis, we list the parameters. Then f3 can be stored. Now, once you have a function pointer, now we can call it. Okay, you can call a function through a function pointer. So what you do is, when you have an integer pointer p, and then to have access to the value in n is retrieved by star p. Now star is an indirect operator, dereference operator. So similarly, when you have a function pointer, you can call function with a dereference like this, and then when you call the function f1 or f2, I need to provide an integer. So 10 is there, something like this. Then let's compile the program, g++ test.cpp. And then let's run it. So f2 10 is there, since f2 is the last one stored in f. Now if I delete this part, compile and run, now f1 is called. Similarly, I can call fd function with some double number there, compile and run. So f3 is called, something like that. So this is a concept of a function pointer. The reason why we are studying function pointer is in traversals, in order, post order, and pre-order, we have implemented that. But here, this in order function call always does printing the value on the screen. That's it. But if we wanted to do something more than simply printing, so this part should be an unknown part. To do so, we could provide a function that instead of printing something on the screen, we can call whatever function is provided by the programmer and then just activate the function so that we can make this implementation more general. So utilizing the function pointer, we are going to update those traversal functions in the next video.